So the chain rule, we're going to have two different versions of it right here. This is the way I like to teach it. But we'll need this one for when we do the end of the notes, and we're not even going to do those till next time. So we're going to concentrate on this. Okay, first of all, we have to talk about what a composite function is. Okay, you can tell me what a composite function is. Absolutely. Function inside a function. For example, like sine squared of x is a composite function. Okay? What are the two composite functions that make up this? Like, say, f composite g. So, f, then g. What do we do first? What do we do first to make sine squared of x? If we knew what x was, what would be the first thing we do? Take the sine of it. So that's your first, that's your inside. So g is sine of x. Okay, and then what would we do? Take that answer and square it. So that's your x squared. So if you take sine into the x, that's how you do a composite function. Take the sine into here, you will get that. Remember, which is the same as that. Now, we've done the derivative of sine squared before. How do we have to do it? Very good, Caitlin. We had to do the product rule. We had to make it sine times sine into the product rule. Okay. So, anyway, sometimes you can choose a different path if you don't like it. But, anyway, this is how it works. Look at the algebra. Certainly makes sense if you remember how to do fractions. dy dx is the derivative. That's how we write it. Okay. What happens is we change dy to terms of u, and we take the derivative in terms of u, and then we take the derivative of the u in terms of x. And look at the algebra dy. Now you don't have to worry about that because it'll all work out. Let me just show you how it works with an example. Okay, so we're using this method, not this one. All right, y equals sine of 2x. First thing we're going to do is figure out how that is a composite function. Now, again, don't think every function out there now is a composite function. It's not. Okay, question? Are you sure? I know. Okay, so now, here's what we're going to do. We're going to write this in terms of u. Instead of both of them in terms of x like we did here, we're going to write it in terms of u. Okay, so here's what we're going to do. Sine of u. And what's u? 2x. All right, so now what you're going to do is you're going to take the derivative of both of these pieces. Because this piece, if we take y prime, is the derivative of u, sine of u, sorry. That's this piece. Derivative of y in terms of u, okay? And then we're going to multiply by this piece, which is the derivative of u with respect to x, okay? All right, what's the derivative of sine of u, Jenna? Cosine u, very good. Okay, and what's the derivative of 2x? Make it count. Very good. Now, that's your derivative, but it doesn't make sense because you made u up. So put u back in, and you're done. So what is it? I'm going to pull my 2 around front. Cosine u, but instead of u, I'm going to write 2x. That's my derivative. That's the chain rule. Okay? The hardest part sometimes is figuring out that. What is the composite? But remember, you did this in pre-calc. You just have to say, okay, if I put that here, if I put 2x inside u, I will have sine of 2x. Okay? And there's really not a lot of variance with that. It is kind of, it's how you're going to do it. Okay, any questions about that particular problem? Yes?
What is the point in changing it to u instead of just keeping it like sine of x?
Because it's not sine of x, it's sine of 2x.
So why can't we change the derivative of that to, is it because we have to separate it to sine of u times sine of x?
Yes.
Okay.
Yeah, because you're dividing it like this. All right, let's, here's the basic thing. Anytime you don't know how to, like tangent of x squared, that would be where u is tangent of x. Okay, anytime you have something differentiating besides your normal x. Now, I wouldn't use the chain rule for this. If y equals 3x squared, I would write that as 9x squared, so y prime is 18x. Okay? Use the chain rule, you would say that is u squared, where u is 3x. Derivative of u squared is 2u. Derivative of 3 is, put your 2 times 3 together. Put your u in there. What's u? 3x. There's your 18x. But we made it more complex by doing the chain rule when it was a quick do your algebra. Okay? So you still have that maybe technique. You may not want to go I'm trying to drive home that not everyone now, every problem now is a chain rule application. Okay, let's try this. Find the derivative of f of x equals tangent of 5x squared. All right, create the composite function. That's probably the hardest part because your derivatives are going to be the regular derivatives that you already tested on. Those. Okay, what's my composite function? Kathleen. Tangent of u, you mean?
Yes.
Okay, where u is?
5x.
Nice. Okay, if you put this and put it in that spot, you will get that. That's how you know you have it right. Okay? All right, now y prime says take the derivative of each piece. Derivative of, you don't have to write this out. I'm just going to be clear. Okay? All right, what's the tangent? What's the derivative of the tangent of u, Christine? So you get squared u, good. Now, you have it memorized in terms of x, but you just have to adjust to make it u instead. Okay, because if you put x in there, you're going to miss substituting u back in. All right, what's the derivative of 5x squared, Holly? 10x. All right. I'm going to put my 10x back out front. I'm going to make this secant squared of u. U I made up to be 5x squared. That's it. It's done. That's all you can do with it. Okay. I know some of you do this. Oops, sorry. You do this. It just is weird. Okay. Make sure you put the dot in there. Also, probably for the calculator does that parentheses automatically, so be careful of that. All right. I don't know that I have any examples. If I don't, I will come up with some, but sometimes you have to do 3 chains. Instead of just 2, you have to do 3. And you don't want to use U every time, so if we have to use another one, we usually use V.
You know who 2 chains is?
No.
It's a rapper.
Oh, well, I'll have to remember that tonight.
Miss Lover, can you find one of those? Because just think
Yes.
about it.
All right. So let's see. Y equals 4 secant squared of 3x. Yeah, that'll work. Okay, try your chain there. It's going to be more than 1. That 4 is a constant multiple, so just leave it alone. It's just going to hang around with your U guide. them? No? What? Okay, remember this is how we work it. The first thing we do is the last piece of the chain. Like that's the end of the chain. So the first thing we're going to do is, sorry, I said that wrong. Okay, the first thing we do is the first piece of the chain. So what, if you knew what X was, what would you do? Okay, and do what with it? Multiply it by 3. Okay, so that's your U. Does that work? Yes. Okay, but here's the problem. We don't know how to find the derivative of that. So we're going to have to break that down further. We don't know how to find the derivative of secant unless it's a quadratic rule. Okay, so let's bump this down. And let's just concentrate on this, and then we'll switch everything up. Okay. What could be, and let's call it a V now instead of a U. Okay. So we're not. Don't worry that this is here. Ignore this. Okay. And now we'll figure out the composite for that. Megan? 4V squared. Or V is what? Nice. And then U is 3x. So if we put 3x in here, now we have secant 3x, and then now we have 4 secant squared 3x. Perfect. So that's your chain.
So
all right.
V equals 4.
Y equals 4b squared, v equals secant u, u equals 3x. Okay. Now y prime, I'm going to take 4b squared. I'm going to take the derivative of secant u, and I'm going to multiply all these derivative of 3x. Okay?
And then do it all together. It's secant squared. Oh, secant u and
That's a b, that's a u. Okay? What's the derivative of 4b squared, Kinsey? 8b. What's the derivative of secant u, Emily? Okay. And what's the derivative of 3x, Claire? Now we're done, except we have to put our v's back in. I'm going to go ahead and take 8 times 3. And our u's, right. These and u's, right. V up here is secant u. Well, u is what? Okay, so we'll just put that in. Times secant u, u is 3x, times tangent u, u is 3x. Okay? V, here's V.
I mean, I don't want to do it. I just need to write it out. Secant squared 3x.
That would, yes.
I get it, but I don't get where Megan got the V 4V squared.
Well, that's just practice.
I mean, I can see there was this little girl. She was really nice there. She would always go. I worked at a preschool. She always go you, and this is what that.
Mm.
Scroll through the yeah, like
Okay. So, yeah, the hardest part is going to figure out the composite. The problem is, and I want to wait till you're caught up to go back to say, okay, here's what you do. When we started this out, we started with a simple this right here, 2 chain. Just 1, 2, okay? But we don't know how to find the derivative of that, so that's how you know, wait, we're going to have to break that down, because that's something squared where the something is secant u. Maybe. All right. Okay.
U is strong.
That's the derivative of, get it, u is.
U is kind.
All right. Find the derivative of y equals sine to the fifth x. Okay. Now, remember this is the same as sine of x to the fifth. We just write it like that. Okay, so is it a chain rule? No, it's one chain.
So it is a chain rule.
Yes. What is the composite function? Write it down and come around and look. What is that?
Yeah, I found it.
That's right. That's right.
Was this from our floor?
No. Yes. Now, when you're doing the composite function, ladies, you can do, okay, what am I going to do first? I'm going to put x in, and I'm going to find the sine of it, right? So that's the end of your chain. And then you, nope, that's not it. And then what am I going to do with that sine of x? I'm going to take it to the fifth power.
I did it the opposite way. Is that right?
What's the opposite way?
Like I did y equals sine of u, and then u equals x.
That is not the same. Shoot, sorry. Let me try it again. And let me show you why. If you put x to the fifth in, and it goes right there, is that the same as that? No, this is. That means you take x to the fifth and then take the sine of it, and that's not what you're doing. So that, and you'll do that, that's why you just have to keep double checking your composite, because you'll do it backwards sometimes. All right, we're ready for y prime. Y prime, Hannah, is what?
Y prime is 5u to the fourth times cosine of x.
Very good. Now all we have to do is put the u back in. 5. U is sine. Sine x to the fourth times cosine of x. Usually we write that like 5 sine to the fourth x cosine of x. Okay. This is the same as this, but you might as well write it how you're supposed to write it, because that's how you're going to see it. Okay? So that's that. Try this second one. It's not incorrect, it's just not right. Just finish it up and write it how you're used. It's just like x times 5. That's not really incorrect. You just don't write it like that. I think that's your decision you got to do. You got to make. Is it easier to do some algebra first, or should we do the chain rule instead? I know what my decision would be. What?
I would have gone the other way.
Oh gosh, yeah. That is like, I hate doing that. The strong motivation. Hold on.
Wait, I'm starting over.
All right, you got something going there? Keep going. Yep. Yeah, you're good. That's perfect. No. Do you want to expand? That's the way you should. That other way. No, you do not have to multiply all that out, because once we get to the factors, we're going to want factors. So,
Yeah. Wait, what?
I'll point out from there. So you have to put 2 chains and put solution y on u.
Okay, what's my, I did, but here's the worst thing that I can think of doing right at this moment in time of my life. Multiplying these three trinomials. I hate it because it's so easy to make a mistake. So let's do the chain rule instead. What's my chain, Lizzie? Very good. Okay? Because we're going to take this and put it right here, and we'll have exactly that. Don't forget to check that. Okay. Y prime, we start with the U, Hannah.
3u squared times 18x plus 6.
Okay, now watch your parentheses here, ladies. Don't just put a time sign and then not do your parentheses, because that whole 3u squared gets multiplied by the 18x plus 6, which is the derivative of u. Okay, 3u squared, u becomes, don't forget your squared, 9x squared plus 6x minus 1, 18x plus 6. Now, that's fine. You may see the 3 distributed, but it's not necessary to do it as factored. It's totally fine.
So you don't have to distribute?
No. If it is in factors, leave it factors, because factors is perfect for doing the next step, which we're going to do eventually. Okay? Did you ever get to the end of that problem doing that?
No, like trying to do that? Yeah,
No, it's not fun at all. Yeah. So the chain rule can save you some of that multiplication. That would be your other choice. It's no problem. Okay. Any other issues with those two problems? All right, let's try some more. Okay, this is another derivative that you have to memorize. You might have the page, the green page. Good job. Okay, we have this middle section and these down here, and then we're done. But this is one. Okay, A is a constant, but it's not E. So E to the x is its own special case. Remember that. Okay, the derivative of A to the x, like 5 to the x, or 10 to the x, or negative 2 to the x. Okay? If we take the derivative of that, we use this rule. Let's see what happens. Okay, it says the derivative of A to the x is A to the x. So 5 to the x times ln of A. In this case, A is 5. Now, there's not anybody in this world that knows what ln of 5 is without checking that out. If they do, then that's just weird. Okay? All right, so this one, derivative 10 to the x is A to the x times ln of 10. Okay? Yep, because you don't know what ln of 10 is. If it was log of 10, you'd know that. All right, now this one I think is going to present some issues. ln of negative 2. That's right. So this one doesn't have a derivative, which means it's not differentiable. I'll just put no derivative. You can't take the ln of negative 2. They give you an error. Okay. So that's another memorized derivative. Now let's use it in cooperation with the chain rule. Okay? So y equals 2 to the sine of pi x. All right. All right, when you got your chain figured out, let me know by raising your hand.
I got it.
You know how to find the derivative of that? You know how to find the derivative of that? Which means the answer is no. You only know how to find the derivative of something x, so you bring it. Okay. Good job on that first part. Okay. Most of you have this, right?
Yes.
And then U is what? Sine pi x. Well, we don't know how to do that without another chain because we only know if I'm on the sheet, I can look up what's the sine of x derivative. That's the only one I know how to do. If it's anything else, I gotta break it down. So I'll make that v, where v is what? X. Okay. So there's your chain. U is sine of v. Yes. And v is pi of x. Okay, so here we go. We're ready for, again, that composite function is going to be the hardest part for you because the derivatives are not going to be hard because you already know those. All right, what's the derivative of 2 to the u? Kelsey. That's this one.
2 to the u on
ln.
yeah.
Okay, good job. All right, that's the derivative of that. All right, let's do the derivative of sine of v. What's the derivative of sine of v, Emma? 1 sine of v, good job. And the derivative of pi over x, is the pi over x. Pi x, sorry. Pi, good job. Pi equals 2x and be 2. Derivative is a constant. Okay, now we put our u's back in. Let's see, u is sine of v. I'll do this a little bit at a time so we don't. Cosine v is pi x times pi. Okay, so far so good. Let's put my u in here. I put my v here. All right, I still got v in. So my v is pi x. Put my ln 2, it's a constant, I'll put it over here with my pi. ln 2 pi cosine pi x. It doesn't really matter the order because it's not pretty either way. The order does not matter, I'm just trying to get rid of the dots, honestly. But if you want to leave it in the same order, it's totally fine. It's right here. Arrow's here. I just
So you
usually
don't put 2 ln2 as 1 unit.
What's in it?
You don't put 2 to the sine pi over x ln2 as 1 unit.
No, that's a, ln2 is just the constant. It's ln of 2, whatever that is. ln of 2. Okay, what? It doesn't really matter. I'm just, usually I put the constants, if you've been noticing, I put the constants out front, so then I don't have to put the dot. It doesn't really matter. It just kind of, say, you don't have, if you put the constants out front, you don't have to say, otherwise you got to put a dot. These are the same problem. Okay. All right. Here we go. Okay. More chain rules. No.
Oh, Nick Jonas, yeah.
Oh, yes. That's right.
What's that Rose's head?
That is beautiful. Yep. Go ahead and do the next one.
Yeah.
Okay, good. Oopsie. Nope. Okay, if you're taking the derivative, yeah. That's beautiful. Yeah, do the next one. Good job. Yay. You would have figured that one out. All right, good job, Jacqueline. There you go. You're good. Put your U back in and, okay, yeah, I would put the 3. Wait, what's the derivative of tangent? Kathleen?
Is this good? Is this correct?
That is beautiful. Go to the next one. Yes,
Isn't
I'm
it-
gonna stop right now. Can you give me your front, just so you don't have to keep rid of the dots. That is beautiful. Just like keep it.
Wow, thank you.
Wait, that was nice. It's like,
That's the first time you've ever said.
All right.
I'm just,
Oh, that's good. Good.
yeah.
what's up, man?
It's really not that big a deal.
Okay, let me make sure we're good on here. We got tangent of u, where u is 2x minus 1, everybody. Y prime, secant squared of u times 3. Hold the 3 around front, put your u back in, you're done. Okay? Now, number 2, hold up if you're already working on it. Okay. The first thing I see here is not the chain, but the product rule. So I'm going to start with the product rule. Okay? Good, but it gets kind of weird. So I'm going to start with the
How do you
product.
see the product rule and not the chain rule? Like, I don't understand seeing.
Is it the same? Like if it was different, like X's and U's or whatever, I would have solved the product rule.
Hold up.
Yeah, that's what I'm doing.
And this is, ask, I won't mention her by name, but there are some of my AP girls, this is the hardest part, until you're like, okay, I got this chain thing, to know where to start. Do I start with the product rule? And honestly, you could do either, it just gets a little weird sometimes. Okay, so I spelled out the product rule. Okay, now, when I take this thing, I'm going to have to use a chain rule because I know how to find the derivative of tangent of theta, but I don't know how to do it when there's anything other than just one variable, okay? So I'm going to go off to the side because it's all about organization, and I'm going to make tangent to theta. What am I going to do? What's my chain? Where u is good. Okay, see how good you are getting there already? All right, now we're going to do the derivative. What's the derivative of tangent u? Okay. I'm going to go all the way to the end of this problem, and then when I'm done, I'm going to put it back up in this space right here. Okay, so 2 secant squared of u, which is 2 theta, is going right here. 2 secant squared of 2 theta. Okay? Did I lose anybody on that problem? All right. Carry on. And then you're going to have to use it again. Okay.
No, it's literally my stomach.
How is your stomach?
Yeah, it's like, no, literally, it's my, like, it's really messed up. No, I'm sorry.
You could drink some apple cider vinegar.
I'm having
Just like a tiny bit in water. It's really,
I
Straighten
love
things
that
out.
side of my brain. I keep
So
telling
next,
no, I keep telling
you water it down.
It's nasty.
But it works, I'm telling you.
It's great. I keep it in my bathroom.
All right, did everybody get this finished? What does it look like? Now, and some, okay, did I miss anybody on this problem? After Kenzie's party? What if it was a real problem? Then we'd be like, she would have admitted it, okay, so you can start combining, you can factor, whatever, just try to simplify it. You don't have to factor if you don't want to. For example, you could write this as 2 secant cubes. And then this as 2 secant 2 theta squared. Secant 2 theta tangent squared. And that's totally fine. Okay? You want to leave it, if you want to try and factor it, or maybe use one of those identities, but that's really good. Okay, how would you factor it? If you decided, and you would factor from here, what would be, I don't have a 2 in common, what else? Secant 2 theta, that's it. Okay, and then I've got 2 more, right? Plus, I got the 2, so I got tangent squared. Okay, either one of those would be good answers. Okay, all right, try this one. Killing you? Why? Oh, to the 1/2 power. What?
Like, look it up.
It's beautiful. Yep. And you can do both of those, so you're good to go. If you couldn't do them, you'd have to put it down slower. You can do those. Yeah, that's good. Yeah, that's good. Good job. Figure it out, Jacqueline? All right. Yes, that's perfect. That'll work. You're gonna do both those pieces. Yeah, that's good. Do what? No, it's plus in there. Yeah.
Miss Ellen, should I do anything now?
Whoa, you don't want to do that. When you take the square root, you can't take individually. Remember, this is not this. Just want to leave it as, that's your U. Take it as a unit.
Did you buy that necklace with that shirt?
No, I understand. This needs you to pull down to the bottom. Usually we write this positive excellence. We're simplifying.
Okay.
Okay, so I'm gonna start this. If you need help, look up. Oops. I'm just gonna spell it out here. You know, I think y'all are beyond this, but.
No, you bring that down, but you don't bring it.
Oh, yeah.
I think it's my sticker.
factoring. Okay, I'm not done yet, but I'll pause there. Nope, I didn't. This, right here, we want to make sure that simplifying, you write with positive exponents.
That's what negative. Did you actually leave this square off of your
No, I factored this here
okay.
into this. And you'll see why. And then it's very bad how it works now. Nope.
Can you see what else would you do?
You see it? Okay, do it.
Actually,
We put the 1/2 to the bottom, just this piece, not the 2. Just the negative 1/2 to the bottom as a positive 1/2 exponent. It's not X, but it's just 1/2 part. Yes, nice. Good job.
this is to the one half.
Why is that? Why is that transfer to 1? No, it's any squared and secant squared. And you're thinking about the 1. All right. Did I lose anybody with this problem? Keep going. Okay, so I did square derivative here, and then I saw right here. This is all multiplication, so I plugged my u back in to the negative 1/2 power. It's always considered simplified when you write a positive exponent. Okay, and then while I was factoring, since everything's already kind of factored, I went ahead and factored this piece and took out secant right here. And I got tangent plus secant. Okay, then I brought, to make this negative 1/2 positive, I brought it to the bottom. Okay, now what else can we do? I can combine these because they're the same thing. It's like having, I won't use x because the x might be confusing, but if I have y to the first and y to the 1/2, how does that combine? Y to the 1/2. In this case, y is that thing. So, 2, what's my final answer? Secant x, parentheses, to the 1/2. Which is also, if you're looking at the back of the book, you're like, wait, where did that radical come from? That's the same thing, remember. I don't care. I really care. The book will probably, if they start with the radical, they will probably end with the radical. But I personally do not care. If you want to end with a 1/2 power or a radical, I don't care. No, this is it. No, there's no more cute. No, that's as short as you can be. Okay, good. Any part of that that's confusing? Okay, I got a couple more. I got 1 page and then I've got some that I haven't. All right. An equation of the tangent line and the normal line to the curve is 2, 3. So what are we looking for if we're talking about this tangent line? The derivative, because the derivative is what in regards to the tangent line? Slope of the tangent line. All righty. Very good. Okay, so let's find y prime. Similar to the last one. This first turn out anyway. You do you. You do you. So, what's that a third? It's a square root. Okay, good. Very good. Okay. Don't forget to put your U back in. All right. Okay, now. Combine my. Okay, so far, here is my derivative. Okay, now you can spend a lot of time simplifying, but remember, you're going to put a number in there, so there's really no point in getting it all pretty like we did on the previous pages. What are we going to plug in? 2. X equals 2, right here. Okay? So, even if you didn't have your 3 and your half, or your 3 and your 1/2 combined, it's still going to work out. There's a 4. Depending on your algebra, negative 1/2 sometimes gets weird. You might want to move it down, but you'll get better at that. I do know that. So what's 9 to the 1/2 power? Negative 1/2 rather. No, it isn't 3.
Why wouldn't I just say radical 9?
It is, which is what? It's not radical 9, it's radical 9 to the negative 1 power. That's why you might, yeah, I think that's probably a good idea for most of you. Okay? Let me start over here. All right, we got 3, we got 2, 1 plus x cubed to the 1/2, and we got x squared, and we're putting in 2. So 3, 4 on top, 2, 9 to the 1/2, 12 on top. What's 9 to the 1/2 again? Square root of 9, which is 3. 12 over 6 is 2. That's my slope.
You lost me when you moved it.
No, I moved it because it's a negative 1/2, so I moved it down and made it a positive 1/2. Excellent. Yep. What? 1 plus x cubed is 8. 8 plus 1 is 9.
The slope is 2. I thought mine to the slope was 2.
So you're going to do whatever you need to do with that negative 1/2 so that you can solve it, not necessarily put it in the calculator. That negative 1/2 messes you up, make it a positive 1/2 by moving it. Okay, so that's my tangent slope. I'm looking for an equation of my tangent line. You can give it to me. Y minus equals x minus, very nice, and a normal line, y minus equals, good, x minus, very good, Emma, done.